morning, everybody, to this webinar. My name is Alex de Ruijter. I'm one of the co-founders of Resilium. Just to introduce myself a little bit, my background is in cognitive psychology, which ties in a little bit to the topic of today. But at the moment, I am mainly developing software. So I'm one of the developers on Riskrunner, which is a software platform that we develop at Resilium. Yeah, that's sort of it. So at Resilium, we help companies manage their risks, and we do that with some consultancy, some training, and some sort of software. But today, what I wanted to talk about, was monitoring behavioral barriers. So for this webinar, I'm sort of targeting probably like half an hour, perhaps a little bit more, but we'll have plenty of time for questions. So I split it in two parts. So first, to just talk about what monitoring is. So we have a bit more understanding on that, and then the behavioral barriers part. And then hopefully at the end, yeah, we have like I can give you some nice, like at least things to think about, and perhaps you have some questions, and then we have a discussion on it. That would also be nice. So let's start with the monitoring part. So if you take a look at ISO 31000, the general risk management standard, there's this one section to the side of it called monitoring and review, which I'm not sure if it gets the attention it deserves. So I think mainly people, when they think risk management, they're more working on the center, along the center part. So setting your scope and your context, and doing an actual risk assessment, and then there's some actions that come from that, and you should like implement those to get your risk down to alarm level. But there's also this monitoring and review part to the side. So what I've actually done is I've taken this like the content of this and visualized it in a slightly different way. Like this, and so I'll walk you through why this is nice to look at it like this. The content of the ISO 31000 is still there. So you basically have, let's say, for instance, you're going to construct a new power plant or some new facility. So there's some like scope and context and criteria for doing that. So in this case, the scope would be like we're setting up a new power plant, for instance. And there's all this stuff that we want to achieve with it, and there's some legislation around it. But of course, sort of you have this at any time you do a risk assessment, also if there's an existing installation already. Then you identify risks for that new power plant. You analyze, so this would be like a hazard, for instance. You analyze them using something like a bow tie. And some risk matrices. Then you evaluate to say whether you're good enough or not with the barriers you have planned, and if not, you need to add more barriers or improve existing ones. And that's sort of the main sort of part of the ISO 31000. But then the monitoring and review, you can visualize as this extra circle where you're going to execute maintenance on what you've thought you should do, and then verify that the performance of all the controls that you have in place is actually okay. If there's any structural degradation, you want to identify that. If not, then you just continue in your little loop, executing maintenance, verifying barrier performance, and then seeing if there's any structural degradation. So like if there is a structural degradation to your process, then you want to sort of make a change, right? And then you go into this like longer loop of actually changing your process, and then you need to do another risk assessment and like figure out if that's okay, and then how you're going to manage all those risks. So far so good, I hope. That we have basically these two two big processes. So one is like designing or changing the way you work, and then one process is about maintaining the current way you work. Right. So once you've decided on a way of working, then you want to maintain that way of working. The focus on the green part is mainly on risk. So either with you have your risk matrix as the focus, and you want to get from your like inherent to your residual, and it's a lot on what is our risk level and how do we get it down to an acceptable level. I would argue in our case for the maintain phase that we should focus on barriers. And there's a couple of reasons for it. We can get into it a little later, but the main, let's say, argument for focusing on barriers is that it's let's say if you verify your barrier performance and you find out that some of your barriers are not performing according to their requirements, so they're a little like below what you want them to be, it's actually very tricky to then figure out like what does that do to the risk. Like if we have a couple, let's say 3 barriers that are performing not as good as they can, does that mean the risk is now like 100x higher or lower? So that's a very tricky question. And so in this, like when we're maintaining, it's good to just focus on the barriers on their own and just say, if we have these barriers, we're going to assume that the risk is under control. And so we're just going to maintain the barrier performance. We can actually, this is, I think, one of the points we could, people might have questions on later, so we can dive into it more later. For now, this is my statement. Like in this maintenance phase, we're going to focus on barriers. Actually, when I say maintenance, by the way, I don't just mean technical maintenance, right? It's also behavioral maintenance. That type of maintenance just looks different. So it's about like training people and like refreshing their attention, like pointing them to the right places to look. And okay, so if you take these two circles or these two like processes, you can also visualize that like this. So if you build our new power plant, you go through this phase of like building with early design, where you figure out what should my barriers be, like what should the distance from the environment be, and at some point you go through detailed design, like where should my fire escape routes be, and at some point you do commissioning, so you actually start building everything, and then at some point you start operating and maintaining. And when you start this, you should have like all the barriers that you've decided on, they should be in place. And this is when you start to track the performance. Of course, before this time, there is no real barrier yet because you're still building all of them. But at some point you start operating, and then you have a set of barriers and you need to be monitoring them. And so this, of course, in this section, for instance, I've said like, oh, then we're going to do a monthly performance review. This is not always true. Like this really depends on the type of barriers and like how critical they are and how changeable the barriers themselves are. But at some point you're going to review, is my barrier still working according to the specification that I made for it? And let's say at some point you find out that the performance of these barriers are sort of falling off, dropping off. Then it's time to do an extra review at some point. So you want to do essentially in this process, do an extra review at this top part to see, do we have some structural degradation here? And if so, we may need to change our process and really do like some big changes. Or we need to have some extra maintenance. So we're good as we are, but we just need some extra maintenance to get us back to a normal situation. Now, the decision whether to go with this green route, right, when you do this extra review or just stay in your, like, I'm maintaining the same barriers, is basically trying to figure out, did the environment change? So do we have like, is something different now? So that suddenly makes all of our barriers start to degrade over time. But if the environment is all the same and you're like, no, we should just like pay extra attention and we're just going to keep doing what we're doing. And then, oops. And then executing the maintenance, let's say, with more attention. Okay, so that's sort of a rough introduction to monitoring and how that plays a role in the larger ISO 31000, like the normal risk management framework. Then we can do questions now, or perhaps at the end maybe better. But okay, so this is sort of part one. Part two, so monitoring the actual behavioral barriers. So we've done monitoring, what that is, now the behavioral barriers part. So what are behavioral barriers? That may be a good question to ask to start with. So this is how I always explain it. Let's say you have a concept called detect, decide, act. So this means that if you have a barrier, that there's a detection phase, a decision phase, and then an act phase. So and depending on how you implement these different phases of a barrier taking an effect, having an effect, that determines whether it's a behavioral barrier or more of a technical barrier. So to give you an example, if I do defensive driving take that as a barrier, then the way that we do that barrier is by detecting the environment, like the other cars and what the weather is like, and then deciding on, okay, I'm going to take back speed, I'm going to go around this car, and all of those stages, so the detecting of what's going on and then deciding on what action to take based on what you're detecting, is all done by a person. And if that's the case, then we call it a behavioral barrier. On the other extreme, if the detection, the decision, and the action are all done by some type of hardware or technical system, then you can call it an active hardware. So for instance, pressure relief valves, they have some sort of built-in way to detect the pressure, and then the decision is of course like built into the hardware, but the action is then to release. And so that in that case, there's no human involved, so it's just pure active hardware. Of course, you also have combinations. So you have where a part of it is done by a person and a part of it is a technical system. So, for instance, if you have a smoke detector and it goes off, that's a detection mechanism, but it's technical. And then if the action is we evacuate the building, that's a behavioral thing. So then you have like a combination of these two things, and then it's a socio-technical barrier. So that may also be like when we talk about behavioral barriers, those are sort of the pure ones, let's say, that are only behavior. But there are some like gray areas, of course, where it's a mix, right? And these are sort of the socio-technical barriers. The other two at the bottom are not super relevant for now, but okay, they're on the slide. So continuous hardware is about stuff that you turn on and then you never turn it off, and it just acts continuously. So like a ventilation system, you can turn it on and then you just keep running it, and there's no change based on some detection. Active corrosion protection, where you run a current through a pipe, is another example. You just keep running it, and there's no action that follows a detection. The passive hardware is like a little bit similar to continuous hardware, except that you can't turn it off. You cannot turn it off. So it's a dike or anti-corrosion paint. These are things that you just apply and you build them, and you can never turn them off. And they also don't detect anything. They just sit there being a dike. The difference with continuous hardware is that you can turn those off. Okay, but for now, that's sort of my explanation of what a behavioral barrier is. It's basically where the person is doing all the work. So it's good to question, like, why is it difficult to monitor these barriers? Because I think they are notoriously difficult to keep track of, like, are we doing a good job or not? It's more difficult than technical barriers, generally speaking. So can we come up with some reasons why it's so difficult? So one reason I would give is there's often a mismatch between how you prescribe work to be done, and then how it's actually done in practice. Sometimes it's called like the work as done versus work as imagined, this sort of mismatch between what's written and then how it's actually done. This is how I like to think about it. So if you take these two axes, so one is like the variability in the work, so how different the work can be. And then on the other axis, you have like how your procedures are written, whether they are very strict or very more like loose and more goal-based. These two should be ideally in sync with each other. So if you have a high variability work environment, you should have more goal-based procedures. So if you do, I gave some extreme examples here, but let's say you do extraction out of a war zone. That's a very high variability environment, right? Where you cannot really predict what's going to happen. And so in those cases, you want to have more goal-based procedures that give more freedom to let's say adapt to the local situation. On the other extreme, there's also stuff where you don't want any variability at all, or like yeah, there shouldn't be a lot of variability. And then also the procedures are written more strictly, so you adhere to the letter of what you need to do. Like starting up a power plant, there's not a lot of room for error. You really want to have that as a pretty fixed process. And then there's some in between where you can pick between different ways of achieving a particular goal, but you do want to have people within a certain boundary of what they're allowed to do. But they can, for instance, pick between 3 ways of constructing a scaffold, for instance. And so this is more like a guidance part, but like a guidance procedure. The trouble starts when these two are not aligned. So of course you have some sweet spots for each type of work, but then there's these like areas where they're not in sync with each other. And I've tried to sort of give some words to these areas. Where, for instance, you have people that follow the rules exactly, but the procedures are written very vaguely. So that might be a sort of more a tribalism situation where like subcontractors start interpreting the rules and they follow them exactly. And a nice one, I think, if you have too much detail and everybody follows the rules exactly, you get very brittle operations. So basically, it means that you cannot adapt to any new situation because you've written everything to the letter and everybody follows it exactly. And then when something new arises, stuff breaks down. The other extreme would be anarchy, where it's like too vague and the procedures are very vague and you have no standard way of working, then it's just anarchy. And so there's some like nice, I think, areas here to consider, like where you are with certain operations. But if you're in this situation where you are not in this sweet spot, then monitoring will become very difficult, of course, because you think you're monitoring one thing, but then what happens in the operation is something completely different. So ideally, these two should be aligned. There's a nice article that was written a while ago now, actually 10 years ago, about this topic, about having a procedure that matches the way of working more closely, and splitting a procedure into multiple types of rules. So you have like action rules in this example. They call it an action rule, and so that's a rule that describes like a detailed course of action. So in detail, like the steps you should take, and then you have more like goal rules, which are more higher level. So I think this is just a prerequisite, and one of the big reasons why monitoring behavioral barriers is difficult is because you're basically just misunderstanding what the behavior is that you're actually monitoring, because you're looking at the procedures and it doesn't actually match with what people are doing in reality. The second is, let's say you have a good procedure for the type of work. Then you still need to make sure that how you monitor that type of work also matches up. So if you take a look at this chart again, and you think about like, okay, extraction out of a war zone. If I'm going to monitor how that was done, I cannot really make like a standard checklist for that, right? Because it's just a different situation every time. So it needs to be more descriptive, or like a storytelling almost, of like, this is what happened. And uh, it's difficult to make like a 5-point checklist out of that to monitor how it went. Um, for the other extreme, so like starting up a power plant, it's a little bit easier to figure out like these are all the things you need to hit, and we have like a structured checklist to go through. And then for the middle, there's some middle ground, of course, where you can have some structure, but you need some comments from people to have it make sense, right? So we did it because of this reason, and they give some extra guidance to it. So I think this is another reason why it doesn't match up sometimes, is that you didn't the way you monitor the work doesn't match up with what the type of work you're actually monitoring. So I think what often happens is that people try to make a checklist, like a simplified checklist for work that's just too complicated to fit the checklist, basically. Okay, so I noted here like self and other verification. This is just what I call it. I've shown this slide in another presentation before, but it's relevant in this context. So like self-verification, these are three different types of verification. So self-verification is where a person that is doing the work verifies themselves how it's going. Then you have other verification, where somebody else that's not doing the work is actually verifying how it's going. And then you have automated verification, which is where there's some type of calculation or some automated way to verify that the work is being done. The last one, the automated verification, we can very quickly like leave that off for now, because that's doing automated verification, like some type of calculation for behavior, is very tricky. This type of verification is more often used for technical barriers, where you have some actual data that's being fed to some database, and you can do calculations on it. But for behavior, this is obviously very difficult. If people have like good examples of where they did this, I'd be happy to hear about it. I think it's in general very tricky. So you're left with the other two. Either somebody verifies themselves, or you have some like an auditor, essentially, so some other verification. I think if you have to choose between these two, there's some ups and downsides. So I like the self-verification a lot myself, because you have the barrier, the people that own the barriers or the controls. It's sort of a trigger to keep their focus on what you think is important. So just the fact that you're ask them about how the barriers are doing, is a trigger for them to keep focus on it. It's also a pretty low effort to set up, because you just need to create these. I'll show you in a minute how we do it, but you basically set up a list of barriers for them to sort of give feedback on. The downside is that it's very vulnerable if your incentives are wrong. So if somebody needs to say about their own work that they're not doing it correctly, that's very difficult, and especially if they're going to be punished for it. So this is super vulnerable to that. A way around that would be that you give them, it's actually a positive reaction when they report, that you give a positive reaction when they report that they're not doing their barriers correctly, either by giving them resources to go and fix it, or having like a helping attitude instead of a punishing attitude. If there's some type of punishing attitude, this will not work, to be honest, like realistically. It's the other downside is that it's high effort in the operation. So it's a lot of work for the people doing the actual work. So a very important thing with this self-verification is to filter the amount of verification that they need to do. So it's not a lot of work. So right, you should keep that in mind always. That's like just a constraint of doing this self-verification. You cannot ask people to rank 30 barriers every day. That's a good way to not get good results. So the other verification is good for stuff that doesn't have a clear focus or ownership. It's good for non-critical barriers as well. So basically for all the rest. It's probably the lowest effort to set up because you have a single person that can do a lot of different topics and you don't have to bother multiple people with it. The downside is more superficial because you don't actually do the work yourself, so you don't know all the ins and outs. It's medium effort and it can feed like an us versus them mentality, meaning like the auditor is like telling like is essentially saying that somebody's not doing their job correctly if you want to interpret it in that way, like in a negative way, and that of course can breed some animosity. Okay, so I just want to show you how we do this in Riskrunner. So here's a bow tie on some cybersecurity bow tie on the ransomware. I'll zoom in a little bit on the left hand side. So you see there's some threads here and some barriers. So using a password manager, two-factor authentication, etc. And so that the bow tie is sort of what we use in this focusing on the risk part. So in the in designing it and like changing it, that's where you need the bow tie. But that's not, we're not going to use the bow tie in our case because we want to just monitor the barriers themselves. So we're going to focus on the barriers. And so then the bow tie itself is actually not a good interface. It's too complicated for people if you just want to get feedback on the barriers. So you shouldn't put a bow tie in front of people if you want to monitor barriers. So in Riskrunner, we made this, which is a separate flow, separate interface, just for getting feedback on barriers. So what people do here is you send them a list of barriers, and they go through it and rank what they think the performance is, and they can like click on the barriers to get more detail, and then they can give comments on why they picked a particular value. So this is especially good if you are in this situation where there's multiple ways to reach a certain barrier, to implement a barrier, then they can give extra context as to why the performance is the way it is. And then for every barrier, there's a separate page where you can then view the barrier performance, including the history of it. So over time, as you sort of collect, you can see that I made this chart today because the dates are all the same. But as you over time collect these performance reviews, it starts to build up a history graph. And then when in this case, of course, it's very positive because it goes up. But let's say it's the reverse. So it goes from being very good to poor. That's a trigger for saying, hey, we need to do an extra review because the performance is going down. And then all the comments are, of course, like tied to these individual data points. So you can sort of see for each point in time, like what people actually said when they said the performance was X, was good, for instance. So just to tie it back, so we have basically the normal risk analysis process with this with the bow ties, and then we do this maintaining process by just having checks on the barriers directly. I think the crucial hurdle, perhaps, or like conceptual like thing, is that you shouldn't try, in my opinion, to figure out what the risk level is when your barrier performance starts to degrade. You should just be managing the barriers on their own. And only when you figure out like, oh, there's too many of these barriers that are degraded, then you go into a full-blown risk analysis again. But in the normal case, you would basically just be looking at the barriers directly. Okay, I think that's enough sort of content for this piece. So I tried to give you some like both, basically these was 2 topics in one, like both a little bit on monitoring and how we think that should be done with the barrier management, and then the behavioral aspect and why that's sometimes difficult. I hope that was useful. Any questions?
Yeah, so we already have 2 questions in the chat, both from Charles.
Yeah. Chat.
So the first question was, do you recommend a behavior-based safety program to monitor these barriers? This question came up around your 20th slide.
I think it sort of depends on how you want to set that up. So basically, it depends on how you interpret that term. I guess like the devil is in the details with this. So we'd have to like have an actual discussion on how you plan to implement it. So yeah, it's a difficult question to like answer like globally.
And then Charles, his second question was, would you classify the self-verification of barriers as a perception survey of sorts?
Yeah, I mean, I guess it's from the way they perceive the world. I don't like if that's what you mean with a perception survey, then yes. It's like subjective. It's from their perspective, of course. And like the part that I didn't include in this webinar was all section around like the supporting evidence. And that's of course also something you can look into to get rid of some of the subjective nature of the self-verification or the other verification, to be honest, like just people looking at stuff. If you want to look into, do we have supporting evidence to sort of justify why we're picking a particular performance value? And so you can have like one or multiple data sources that so an example would be if you have like a speed limit, and you figure out like, okay, what is the performance of like people adhering to the speed limit? Then one way to sort of have evidence whether the performance is good or not is to just have a speed camera, of course. That would be like a very objective way to do it. Another would be to send out a survey to people saying like, oh, how are you adhering to the speed limit? Are you doing it okay or not? And of course, like one is super objective, but it's only tied to one location. The other is a bit more general, but it's very subjective to like people saying, I always adhere to the speed limit. But you can look into that as like, yeah, what are some of the, what can you come up with as supporting evidence to help it make it a bit more, let's say, objective to provide supporting evidence. It's a lot of work though, so yeah. You should probably focus on your critical barriers with that. So you do that for your critical behavioral barriers first. Spend your attention on those to try to come up with supporting evidence. Any other questions?
Yeah. Okay. So one more question came in from Stuart.
Yeah.
So would there be a drive to minimize the use behavioral barriers during the risk assessment and select more reliable or passive barriers?
Oh yes, yeah, okay. So yes, I got that part as well. So yeah, if you take a look at like the hierarchy of control, of course, like you should be able to. So you want to prefer just not doing the activity in the first place, right? Just eliminating the risk, and then you take a look at like engineering it out, and then at some point, you have your procedural controls. So you rely more on behavior. I think you should, in general, prefer technical barriers, probably. Although, in some cases, especially if the variability is high, it's not feasible. So for instance, like, yeah, the extraction out of a war zone example, you don't want to have like some super technical fixed way of doing that. Although perhaps like the robots are coming, so like perhaps it will happen at some point. But in general, if you're if you have like a very dynamic operation, then it's more and more difficult to have technical barriers. They thrive more in a more fixed process. So yes, prefer them, but I think in some cases it's just not feasible to have technical barriers, and then you need behavioral barriers because people are really good at adapting. Any other final questions? Yeah, Stuart. Okay, so I hope it was helpful, like at least triggered some thoughts. If you want to know more about Riskrunner, you can go riskrunner.app/sign-up, or just send us an email or call us. We can tell you more about it. And then have a nice day, everybody. Thank you for your time, and I hope to see you in the future somewhere.
Thank you.
Cheers. Bye.
Thank you, Alex.
Cheers. Bye-bye.
Thanks, Alex.
Yeah, bye.
Thank you.